How could we check if a given point x, y is a solution to an equation? We have previously done plug in one value to find the other value, such as substitute x value to find y or y to find x. So now we are going to substitute both in the equation to see if it makes the equation true, both sides are equal, and then it's a solution. If both sides are not equal, it's not a solution. So there's three different ways we are going to learn. One by graphing, one by plugging in the equation, one using the table. How could we check if a point a xy is a solution to an equation? Is the point on the line? Look at the graph and check if the point is on the line. Does it lie on the line graph? If it doesn't, then it's not a solution. If it does, then it's a solution. Does it follow a pattern on the table? So check the pattern. Are we adding and subtracting by a constant number? Finding the first difference. Same as arithmetic geometric sequence. If finding the first difference, is it a constant number? And does that point fall when we are adding by a constant number or subtracting by a constant number? Is it in the table, that set of point? Does it satisfy the equation and make it true when we plug in or substitute in the equation? Both sides are equal. If both sides are equal, then it's a solution. If not, then it's not. Let's check using table. Is 2, 7 a solution to equation y equals 3x plus 1? So we see on the x value you are adding by 1. Adding by 1. Every time you're adding by 1. Now on the y value you are adding by 3. Negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. So we see the point is on our table, so it's a solution. Is a solution. Let's check using graph. Is point 27 a solution to y equals 3x plus 1? So y equals 3x plus 1 is in slope-intercept form. We know our y-intercept, we know our slope. Y equals mx plus b, where m is the slope and b is the y-intercept. So we know y-intercept is 0, 1, and our slope, the rise over run, is 3 over 1. So we are going to plot 0, 1 first. 0, 1. This is our 0, 1. Now we go up 3 using our slope. We go up 3 and right 1. Up 3. 1, 2, 3 and right 1. and right one. So that's our next point. And we repeat again. Up 3, right 1 from the next point. 1, 2, 3, right 1. Now if we connect it, we can keep going, or we can go down 3 and left 1. We see this point. I'm stopping here because it's on the line. This is 2, 7. It's on the line, this paper one. So it's a solution because it lies on the line. Let's check using equation. Is 0.27 a solution to y equals 3x plus 1? We substitute or plug in 27 in the equation. Y equals 3x plus 1. So this is our x. This is our y. X is 2, y is 7. So we plug in place of y we plug in 7, in place of x we plug in 2. We have 7 equals 3 times 2 plus 1. So 3 times 2 is 6, so we have 7 equals 6 plus 1. 6 plus 1 is 7, so 7 equals 7. So left hand side equals right hand side, so it's a solution.